Hi there. So welcome to the Polymer State of the Union. Not sure how familiar you are with State of the Unions. I'll try and make this a lot more interesting. But you may all, like half of you may have to stand up and give standing ovations like every couple of minutes. So I hope you warmed up, did some squats, that kind of thing. You should be good. So just a little bit about me. My name is Matthew McNulty. I lead the Polymer team here at Google. My Twitter handle is there. It's Matt S. McNulty. Feel free to stalk me. There's a lot of young British women who think I'm an actor over there. So they stalk me, and they are similarly bored. So feel free to join them. For the sake of this talk, I'm going to assume that most of you know something about Polymer as well as web components, and that you paid attention to Dimitri. Just in case, I'm going to spend just a minute or two talking about what Polymer is. Oops, wrong button. So Polymer is a library that helps you build elements and apps out of web components. So this sounds like a lot of JavaScript frameworks out there, but Polymer is different in that it uses web components, what Dimitri was talking about, this cutting-edge set of standards. This lets it do less work to achieve better results than what came before, and frees up framework authors to concentrate on making great apps. So how great can apps be? Turns out with Polymer, very great. So it's easy to say, but let's take a look. So first I'm going to show you a mail app that one engineer wrote in just 2 weeks. So granted, it was Eric Beidelman. He's pretty awesome. But still, it was one dev in just 2 weeks. And I get to do a demo on a screen that's really far away. All right, so first off, let me make this clear. This is not Gmail. This is just a sample app that we wrote in Polymer, but it does use the Gmail API and Google sign-in and authentication, which I can sort of see my mouse. No one email me at those other email addresses. Forget you saw them. So the Gmail API and the sign-in authentication API are just part of more than 250 different APIs that Google makes public. So the Google Web Components project, which is a project we started to turn those APIs into web components, is at googlewebcomponents.org, I believe. And managing some of these APIs can be a pain, but Web Components reduces the boilerplate and makes it so they're really simple to use and really simple to integrate into an app like this really quickly. So let me find my cursor again. There it is. So here we have an app that's really, really close to the native Gmail app. You can see if I scroll it, it's got a really cool material design, crossfade scroll thing. I can also select items. It's got some cool ink effects there, undo it. It's got an app drawer. This stuff is it's pulling like this profile data from Google+. It's profiling the tags. It's pulling the tags from the Gmail API. This is all a real app with real data. And it's even responsive. I can bring it really big, and it adjusts automatically. It still has all the really cool effects. So anyway, so you can swipe messages. You can do swipe to delete, undo it. And it all just works really well. And this just uses the web platform, uses web components, and uses Polymer. Let me get back here. All right, so now we've seen what you can do with Polymer and part of what makes it different, but let's dig into it just a little bit more and see what makes it unique. So we make a big deal out of the fact that Polymer is a library and not a framework. This goes back to using web components and really using the platform. So a long time ago, web apps were written in HTML and using built-in tags like button and form. So Polymer returns to that world, but this time with custom elements. And with Polymer, developers write HTML, but the framework is DOM. We don't build our own framework on top. Polymer is just a really thin layer on top of that new and improved web platform. So that's great at a high level, but what does it actually do? So the first thing it does is it sugars the primitives that make up web components. So why does this new hotness that Dimitri just danced around and talked about need sugaring? It's because like all good primitives, web components are really low level. And that makes them really flexible and really powerful, but not quite as easy as they can be. And Polymer helps that out. So Polymer also reduces boilerplate, keeping your code limited to just what's unique in your application. And it adds a declarative syntax to web components. This is in the spec, but no one's implemented it yet, including Chrome. And this allows you to develop in markup, which makes it really simple. And most importantly, Polymer has an opinion. It's how we think elements and applications built with web components should be built. So here's Dimitri again. This is an actual picture of him working on web components. I definitely didn't Photoshop this yesterday. It's definitely not my wallpaper. So this is just a little history lesson. The state of the art for a long time has been JavaScript developers building their own platforms on top of the web, because the web platform wasn't good enough. But now with web components, it is. And Polymer is the next step in that story that Dimitri was telling earlier. It's the experiment to prove that web components are awesome, to use his term. So experiments have results. How have we been doing? So Polymer has a lot of really great features for making building web apps easier. So developers love them. We've had 1 million unique visitors to Polymer. We're in the midst of holding a bunch of education events around the world called Polytechnics. 119 of them so far. And 85% of the participants say they're going to use Polymer in their next project. So on our little report card here, I'm completely biased, but I think we get an A for that one. So grading yourself is the best kind of grading, in case you don't know that. So how about productivity? So Polymer lets developers build applications faster and with less code. So QuickOffice is a user of Polymer, and they removed 10,000 lines of code when they moved to Polymer for their document renderer. So, and again, the mail app I showed earlier, written by Eric, came from 1 developer in 2 weeks to build a really polished, really nice web app. So let's give that one another biased A. We've also built a lot of elements that developers can use as is for their apps. You saw some of those in the Gmail app. These are built with Polymer, but they're not Polymer. They're a separate thing. We have a few different sets. We have core elements. We have paper elements for functional and UI elements. And we expect there to be a lot more of these. So, and you saw, paper elements are our material design elements. And material design was this really awesome effort inside of Google, because the Polymer team, the Android team, and the team that works on kind of the iOS framework for iOS apps at Google all worked together side by side on the same project. It was equal partners across it all. So as you can see from the demo I did earlier, developers can build awesome experiences with these. So working on a perfect GPA so far. Mom's going to be really proud. So how about performance? So Topeka, this really cool quiz app we showed earlier at I/O, the Polymer mail app I was just showing, and our sample apps work great. But to be honest, performance is inconsistent. Things take tuning, and they're especially inconsistent on browsers that don't yet support native web components, like Safari. So developers have told us that mobile Safari is super important for the mobile web. They can't just ignore it. But getting quality performance on that browser is really challenging. So there goes our perfect GPA. So I'm going to give that a needs improvement. Mom's going to be pretty mad. But we're progressive optimists here on the Polymer team, so we're going to rephrase that to maximum improvement opportunity. I was going to do an acorn because it's the furthest from a tree, but that was going to get a little too weird. So how about payload and complexity? So these things go together really often. So Polymer itself is pretty lean. It's 123K. It's a 66K gzipped. For an app and like a fully featured framework, that's pretty great. But for a single element, which is what Web Components says you can mix and match on the page, not so much. And Polymer is supposed to be able to do less, which means it should be smaller, because it's built on Web Components. And in terms of complexity, Polymer is pretty complex. It can be difficult to know what's going on if you want to look under the surface and see what's happening. And again, for an app, that's OK. But for mixing and matching all these different elements from different vendors, not as much. So I think we have to admit we have another maximum opportunity for improvement here. So let's look at the whole report card. So ergonomics, productivity, and expressiveness are A's. A for awesome, as Dimitri would say. And performance and payload need some improvement. So this illustrates an issue we've had all along. Polymer has dueling goals. Be this experiment that pushes the platform forward and lives on the edge, but also be something production-worthy for developers that developers can depend on. So we've done a great job at the former, note all those A's, but the latter is clearly a work in progress. But the experiment's over now. Native features have shipped in Chrome. Polymer's fully featured enough to build apps, like I showed you. And we started out with no native features at all when we started this project 2 years ago, and almost no knowledge about how all this stuff would work together, and now that's changed. So now it's time to make Polymer production ready. So in the last month, we've begun to take a hard look at every aspect of Polymer. So we've learned a ton we can put use to making Polymer better. We looked at each and every feature and tried to hammer it down into a leaner, less complex shape without sacrificing the really great features that everyone loves. So we made a bunch of improvements, and we're ready to tell you about them today. So first, we've refactored Polymer into a series of layers. So core features are really fast and really lean. Advanced features that are more costly are opt-in. We strive for the 80-20 rule, so try and accommodate all the common use cases and let the rest opt in to the more advanced features. So that's the first change. Another change is we've greatly simplified our data binding system. So like everything else, we've optimized it for performance and simplicity. So most properties don't require two-way binding, so we've made that opt-in. So if you think of an AJAX request, there's a zillion things you can set, but really only one response that you want to actually listen to. So we've made that opt-in. Polymer's always had implicit types for properties, but we've made that explicit now. And change notification uses events for interoperability across elements from different frameworks. And another thing we're doing is specifically geared at browsers that have not implemented Shadow DOM and the rest of web components. So this change is specific to them and not Chrome. So we have a Shadow DOM polyfill. It's awesome. It's this feat of engineering. It's spec compliant, but it's also pretty intrusive, and because it's a pretty big feature, it's pretty big. So instead, we're going to take the tack of building a shim-style layer that just polyfills what Polymer needs. And the existing polyfill is going to live on for generic non-Polymer web components code, and that's the third change. So those are the high-level changes, but what are the results of this effort? So it's still pretty early. Performance testing is a really tricky art. But we have some results to share. So the first thing we tested was startup time. So how long we can go from launch until the app is ready to use. So first on Chrome. So I've always wanted an excuse to use that. So like a medium complexity app starts about 5 times faster on Chrome than it was before. So that's a huge speed up. On Safari, the story is a little bit different. So the same app starts up 8 times faster on Safari. So it's more of an improvement than Chrome, but we had more to do on Safari. So Chrome is still faster because it has the native features, but the penalty is reduced to as small as we could make it. All right, so it's way faster, but what about payload and complexity? So we've reduced payload 87%. So it's 15K now, and that's 6K gzipped. And this is with the same features and the same use cases. So we're not quite done. These numbers are going to change a little bit. My team wants me to emphasize that. But you can get an idea now about how we sped things up so much. We went really, really simple and down to the metal. So to be honest, it surprised even us that we could do this without a major disruption to the feature set. But it's fun and easy to say these things, so let's look at actual evidence. Let's go to the videotape. So this is showing Pika, which is a newsreader demo. It kind of does RSS feed reading, which we've had for a really long time. And we've got 2 versions of it running on a Nexus 9. On the left, you've got Polymer, the new Polymer. On the right, we've got the existing Polymer. It's the same app. So that actually went early, didn't it? So let's see the difference. Boing. So here's the same thing on an iPad Air. Gets better. So here's a synthetic test. This is like a medium complexity list, a lot of list data, and a lot of data, actually, here on a Nexus 9. And now here's the same thing on an iPad. And no, it didn't freeze. All right, so let's take a look at our report card again. So we stayed after school, we worked hard, and Mom's much happier now. We've improved precisely where we've needed it, and we haven't touched the features that developers love. Of course, nothing in life is free. So there are some breaking changes, especially when it comes to data binding in certain cases. But it's really not that scary. It will not require a rewrite. So elements might not have to change at all, individual elements you've made. Larger apps might need a few days to a week to adapt, but it kind of depends on the app. Some apps might not have to change really at all. So basically about a few minor version numbers worth of changes, but all at once. So to make sure people realize that, we're changing the version number to 0.8, both to show that we're closer to 1.0 and we're 0.3 better than before. Glad people got sort of a Spinal Tap reference there. So I've got a few other things to talk about too. I've covered what Polymer is already, and I do that every single talk, and all of us do that every single talk. People still get really confused about it, even people that work on web components. So Polymer and web components are pretty big new things, and some people think Polymer is just the polyfills. Some people think Polymer is the material design elements. We kind of like to clear that up. So the polyfills that Polymer uses are agnostic. They work with any other library. Brick uses them today. These are web components polyfills, not Polymer polyfills. And they're generally useful. These polyfills are not Polymer. We wrote them, but they're not part of Polymer itself. So we're going to move them away from Polymer into webcomponents.org. So other library authors or developers can use them without any confusion at all. And the community can improve them independent of Polymer. So we wrote them, but we want everyone else to be able to use them until the day we can happily get rid of them because everyone supports web components. So elements, they're made with Polymer, but like I said before, they're not Polymer. Polymer isn't material design, but we make a set of material design elements. So we're going to take them, we're going to move them to their own part of the website, and I think we're eventually going to give them their own identity and put them somewhere else. But for right now, they're kind of separated out from Polymer. And what's left is the core of Polymer, that 15K, or that 6K gzipped. And now that core is production track. So it means no more fuzzy labels that mean nothing, an actual roadmap. That's still a little fuzzy. So 0.8 is in preview today, so it's live today as a branch of Polymer itself. It's still really, really early. It lacks docs like completely. It's still missing a couple of features, but you can take a look if you're brave. We like to do everything in public, so we've got it sitting there. 0.9 we're going to call beta, will be early next year, and then 1.0 really soon after that. So the idea is we're focused on the core of Polymer. We're going to put it out in production as quickly as we can. So even as an experiment, until now, lots of people are actually using Polymer. So we love early adopters out there on the front lines of the web platform with us, and I have a bunch of them I'd like to show you. So first up is Salesforce. Salesforce is Polymer's BFF. So they're here somewhere. They really, really get Polymer. They've gotten Polymer from the first time we put it out there. They're the people I bring to the office every time the team needs a pick-me-up. And their mobile SDK teams built this whole SDK for their developers to use Polymer to build Salesforce apps. So they built a whole SDK on Polymer and are shipping that to their customers. They've also built a reference hybrid application that runs across multiple platforms, and has secure offline storage, and it uses Polymer that you can see here. So this is actually a product that they shipped this week and blogged about, I think, yesterday. So next up is News Corp. News Corp has this awesome team using Polymer to experiment with next-gen tools for understanding and manipulating data with components and putting that data in the hands of journalists. So it's really, really cool stuff, and it's at the cutting edge of data-driven journalism. And now for some Google products. So YouTube is using Polymer. So for some users, this is going live this week. It's going to be the related videos list to one side for a percentage of users are going to get. We moved over to Polymer this week. So QuickOffice, I mentioned before, they've got a rewrite coming of their whole renderer. This uses Polymer. It's shipping very, very soon. And it radically simplified their code base. So 10,000 fewer lines of code to do the same thing. So Translate is also developing the user interface in Polymer. You may not realize this, but hundreds of millions of people use Translate every single day. Google Play Music is also using Polymer. And Santa Tracker. I'm actually happy that got the most applause. So this is a great story. So I don't know if you guys know this. 1955, a Sears store in Colorado Springs put an ad in the paper saying kids could call and talk to Santa. And they put the wrong number in, and they actually put the precursor to NORAD's number in. So this colonel in NORAD in Colorado Springs started getting phone calls on Christmas asking where Santa was. And this colonel actually happens to be the grandfather of a good friend of mine who works at Google. And he started to just actually give out where Santa is to all the kids. And a tradition was born. So it's a really cool story. You should look into it. So The Santa tracker this is the current one. The Santa tracker that's going to launch this upcoming season uses Polymer, and it's awesome, and it's for all your Santa stocking needs. So there's a whole lot more users of Polymer inside of Google, really too many to actually list, but there's a whole bunch more. So let's wrap up. So that was a lot of new stuff. So in summary, so the next major version of Polymer is coming shortly. It's out today. It's super, super fast, super, super light, and really, really modular. And it's going to require really minimal changes for developers to adapt to. Everything you're doing today still works. And Polymer is no longer an experiment. So hooray, it's a production track. And the polyfills are moving over to webcomponents.org. That's already happened today. And lots of people are already using Polymer, including Santa. And you should join them. Rob's up next. He's going to dive in a lot deeper. And so you can do nothing. And Rob's going to be here in a minute. You don't even have to move. You do something and follow us on Polymer. And we're on GitHub. The name of the GitHub project is Polymer. And come check us out, build a project, and join the fun. Thanks.